Simple mechanisms. Types of movements. Number 1. Oscillating movement is a backward and forward motion, such as a clock's pendulum. Number 2. Reciprocating movement is an up and down movement, such as elevator. Number 3. Rotary movement is a turning movement, such as the turning of wheel. Number 4. Linear movement. This movement in a straight line. Example, dropping an object from a height. The cranks. A crank is a simple mechanism that consists of an arm that is joined at one shaft, or axle that can turn. The other end of the arm has a handle, or a pedal. Cranks change rotary movement into linear movement. Here, we have a simple system of a crank. We have a load here, the crank handle, the drum, and the cable is connecting the load to the drum. So, what happens here is that when the crank handle is turned, it turns the drum which is connected to the rope, which the rope is connected to the load. So, when we turn this here, which is rotary movement, it changes that movement to a linear movement, which is up or down. That means if we turn the crank handle, the bucket will either go up or down, showing a linear movement. Now, what is mechanical advantage of cranks? Here, we have a picture of a bicycle. A bicycle has pedals. This pedal here is the type of a crank. They move in a rotary direction. This gives us mechanical advantage moving forward. So, what happens in here? We use a rotary movement by pedaling, and it creates linear movements, because the bicycle now starts to move. Then here we have a fishing rod. It has a reel that moves in rotary direction. The rodding line moves in a linear direction, either front or back. So, this movement enables a fishing line to be pulled up. Other type of mechanism that gives us movements is our simple pulley system. Now here we have a pulley system. A pulley is a type of wheel and axle that is used to lift weights. The system consists of a grooved wheel that turns on an axle or shaft. The rope or cable runs in the groove. So, here we have our pulley system. This is the load we are trying to lift. This is a pulley that has a groove in it. The rope can go into it. That is the rope, and this is the force, or the effort that you're going to apply to move the pulley. Now, this type of pulley does not have any type of mechanical advantage. That means if you have a load of 10 kilograms, you have to apply a force of 10 kilograms to lift the load. If the object you're trying to lift is 10 kilograms, you will have to exert a downward force to 10 kilograms to lift the object, in an upward force. This means, the mechanical advantage is 1. Now, we go on to a compound pulley system. A compound means that it has more than one pulley. As you can see here, that is one pulley, and there is the second one. A compound pulley is made up of 2 or more pulley wheels. Less effort is needed to lift a load. One pulley is usually fixed, and the other pulley is movable. Now, there is your 2 pulleys, that is the pulley that is fixed, that means, it doesn't move. This pulley here, can move in that direction, or in that direction. There is the effort there, and there is your load here. Now, what is good about a compound pulley is, a compound pulley gives us an advantage, and a mechanical advantage in a 2-pulley system is doubled. This means if the load is 10 kilograms, we have to exert a force of 5 kilograms to lift the load, but the distance of the effort will be doubled. Now, what does it mean? It means, if this load here is 10 kilograms, then where we are pulling it from the effort, we must only add 5 kilograms effort. Although, this is 10 kilograms, but where is the trade-off? The trade-off is if you pull the side of 15 centimeters, the load will only go up 25 centimeters. So the trade-off is that, although it is a compound pulley system, the less effort you put in, you will still lift the load, but you will lift it at half the load. We can then say the effort will be doubled. The mechanical advantage is equal to 2. Let us investigate in cranes. A crane has many types of pulley systems. The first part we are going to talk about is the jib. Is a strut that supports a fixed pulley. So, there is our fixed pulley there, and it is being designed by a strut. Counterweight. A crane has a counterweight, because if it is picking up heavy load it prevents it from tipping over or falling over. Rotex gear. This here is your Rotex gear. It allows the crane to move in any roundabout direction. This here is a boom, gives us length, or the height, and it is a movable arm, and is able to move your load in any direction. Here we have the movable pulley. It provides mechanical advantage to the crane, and there we have the fixed pulley, which is connected to the movable pulley.